Section 7.6 is double angle formulas. So we're looking at what happens when we have 2 times an angle inside of our trig functions. There are more formulas and properties that go with our trig functions. So we can derive these from the fact that sine of 2 theta is the same thing as sine of theta plus theta, and use the sum formula to help us derive the formula for sine of 2 theta. So again, if we think about sine of 2 theta as sine of theta plus theta, we can apply the sine sum formula. So the sine sum formula says sine of alpha plus beta is sine of alpha cosine beta plus sine beta cosine alpha, but in this case both alpha and beta are the same thing, they're both theta. So you end up with sine theta times cosine theta plus sine theta times cosine theta. When you combine like terms, that just becomes 2 sine theta cosine theta. So the double angle formula for sine of 2 theta is 2 sine theta cosine theta. So whenever you have sine of 2 times an angle, you can apply the sine double angle formula, and it's the same thing as 2 times sine of the original angle theta before you multiplied it by 2 times cosine of theta. So we can do the same thing for cosine of 2 theta. So if we think about cosine of 2 theta as cosine of theta plus theta, then again cosine of alpha plus beta, same trig function, opposite sign, so it'd be cosine alpha cosine beta minus sine alpha sine beta, where both alpha and beta are now theta. So you end up with cosine of theta times cosine of theta minus sine of theta times sine of theta. And when you combine like terms, that becomes cosine squared theta minus sine squared theta. So the double angle formula for cosine of 2 theta is cosine squared theta, the original theta before you multiplied it by 2, minus sine squared theta. What you'll notice is I have 2 other cosine 2 thetas here, because you can actually manipulate this and come up with 2 other versions of this formula using the Pythagorean identity. So if we remember, sine squared of theta plus cosine squared of theta is equal to 1, so we can use this to derive 2 other versions of our cosine double angle formula. So I took cosine squared theta minus sine squared theta, and I used the fact that sine squared theta plus cosine squared theta is equal to 1, and solve this for cosine squared. So if I replace cosine squared with 1 minus sine squared, another version of our double angle formula is 1 minus 2 sine squared of theta. And if you do the same thing but replace sine squared with 1 minus cosine squared, another version of the cosine double angle formula is 2 cosine squared theta minus 1. So sine of 2 theta is equal to 2 sine theta cosine theta, and then cosine of 2 theta actually has 3 different versions. You can memorize all 3 of them. They're useful depending on what information you have. Like if you only have cosine, this last one's useful. If you only have sine, the middle one's useful. If you memorize only one of them, I would say memorize the first one, because the other 2 can always be derived exactly how we did with the Pythagorean identity. And you can always find one of the other. If you're only sine, you can always find cosine. But these are the double angle formulas for sine and cosine. And then using this same idea, you can find the double angle formula for tangent. So tangent of 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. In this example, we're given that cosine of alpha is equal to negative 3 over 5, and alpha is between pi and 3 pi over 2. And we want to find the exact value of sine of 2 alpha and cosine of 2 alpha. So this is very similar to all the ones that we've done before, except for now we're going to apply the sine and cosine double angle formulas. So go ahead and pause the video and find sine of 2 alpha and cosine of 2 alpha. The first thing I did is I drew my triangle in the 3rd quadrant because it tells us that alpha is between pi and 3 pi over 2. We know cosine is x over r, so x is negative 3 and r is 5. And then this is a 3, 4, 5 right triangle, so that means that y has to be negative 4. Sine of 2 alpha is equal to 2 sine alpha cosine alpha, where sine of alpha is going to be y over r, so negative 4 over 5. Cosine of alpha, what they already gave us, is negative 3 over 5. So then multiply this together, you end up with sine of 2 alpha to be 24 over 25. So if you haven't already done so, go ahead and pause the video and do cosine of 2 alpha. For this one, it doesn't matter which of the 3 versions of the cosine double angle formula you chose. I put all 3 of them out, just depending on which one you did. Personally, I would do the bottom one because I'm given cosine, so I would choose the one that just had cosine, so I didn't have to think about any extra work. But anyway, whichever one you choose, it doesn't matter. You plug in cosine is negative 3 over 5, sine is negative 4 over 5, square it, simplify. Whichever version you use, you should have ended up with negative 7 over 25. So this has been sine, cosine, and tangent double angle formulas.